Hello, grade 8. How are you today? I hope you all are safe and well. Today our lesson about magnets, the property of magnets. So, what are these properties of a magnet, and what makes them have these properties exactly, or what they are made of? So, please grab your highlighter, open page 136 and follow me. The properties of magnets. Discovering magnetism. What is a magnetism? Magnetism is the force of a magnet that repel and attract. This is called magnetism. And we have also law about the magnetism. Okay? So, a long time ago, the ancient Greeks discovered that a rock that they called lodestone attracted small pieces of iron. Lodestone is an iron containing mineral that is naturally magnetic. The ancient Greeks had discovered magnetism. So who discovered magnetism? The ancient Greeks. So these Greeks, they noticed that this lodestone is attracting small piece of iron. So what is this lodestone? It's an iron containing material, which is material that contains iron, which is mainly magnetic, naturally magnetic. So they discovered that it attracts. So this is magnetism. They discovered magnetism. A magnetic force is a non-contact force. Lodestone, it exerted a force on a piece on the pieces of iron when they were not touching. So what's the meaning of non-contact force? Non-contact force means it doesn't need to contact, or it doesn't need contact to apply the force. It can work from a distance. It can attract something. So if we have a piece of magnet, to make it attract something, we just need to come closer to the object, magnetic object. We don't need to touch it with a magnet to apply the magnetism on it. This is the meaning of non-contact force. Scientists can now make very strong magnets that float or leviate on some other materials. So here now in these new days, new world, scientists start to make, or they could make magnets that can fly, okay, which is levitate, or can float on something. They can just create a magnetic field and the magnet can fly. Attraction and repulsion. What's the meaning of attraction and repulsion? Every magnet has a north pole and south pole. The poles of magnets attract or repel each other. Here we all know the magnet shape. We have half of it blue and half of it red, just to represent or resemble the different poles. They like poles means like ends. Okay, they have two ends called poles. They call them North Pole and South Pole. Why did they call them North Pole and South Pole? Scientists discovered that the north end, like one piece or one end of the magnet, is attracted to the north pole of the earth. It's like the compass, okay? It's like the compass that we are using for directions. All the time, the compass needle, which is magnetic, made of magnet, point to north, and south point to south. Okay, that's why they call them North Pole and South Pole, because they discovered that one of these ends always lies on north, or attracted to the north of the earth, and the other one is attracted to the south of the earth. So here both of them can attract or repel each other. can attract or repel each other. This is the only thing that which it's a property for only the magnet. We have materials, okay, that magnetic, but they do not repel each other. They only repel and attract a magnet, but here the magnet can attract another magnet and repel another magnet. So when do two magnets repel? The north pole of a magnet repels the north pole of another magnet, or the south pole of a magnet repels the south pole of another magnet. Here we have an example. If we took these two magnets north to north, they can repel, they can push each other away, okay? Also with the south poles, if we try to apply the magnetism on them, they will repel each other. So when do they attract? When the north pole is facing the south pole. So here, if you took the north pole and the south pole together, they will attract each other, they will stick, or they pull each other. Okay, what about the magnetic materials? Iron, steel, cobalt, and nickel are magnetic. Do you remember where can we find these magnetic materials? We can find them inside the core of the earth. We can find iron, steel, cobalt, and nickel. We can find iron, cobalt, and nickel. Steel is an alloy. We can make it from the iron. So these iron, cobalt, and nickel, we can find them in the core of the earth. But still we can make it, and 4 of them are magnetic. Some materials are attracted to magnets. These are called magnetic. So what are the magnetic materials? Materials that attracted to magnets. Iron, cobalt, and nickel are magnetic materials that are elements. Some of the alloy or oxides of these elements are also magnetic, like the steel. Steel is magnetic because it contains mainly iron. So this could be a good question. Why steel is magnetic? Because it contains mainly iron. Lodestone or magnetite contains iron oxide, which is also magnetic. So why lodestone or magnetite are magnetic? Because it contains iron oxide. So some of alloys or oxide could be of these elements are also magnetic. The stripe on credit cards are made of a plastic that contains lots of very small iron pieces that behave like tiny magnets. These iron pieces are used to store information on the card. So here we have the credit cards that we can buy something with them. We can use them to buy something. Okay, we are passing these cards on the machine, inside the machine. Okay, this stripe, okay, or this strip contains very small pieces of iron. These small pieces, they can they can behave like a small magnet, okay. It can stick to the machine, and these iron or this strip can store information in it. So when we pass it through the machine, the machine can read what's inside this card exactly. Okay, now let's see how the magnet behave, or how does it attract or repel exactly. What does it have from inside? A piece of magnetic materials is attracted to a magnet, but it will not be repelled by it. Magnetic materials do not attract or repel each other. The only two things that can repel each other are two magnets. As I said earlier, magnet can repel or attract magnet, but materials can attract, but they do not. Magnetic material, they can attract, but they do not repel. So The way to tell whether an object is a magnet is to see it if it's repelled by another magnet. So you can try it with another magnet. If they repelled, not attract, because even magnetic material can attract, but if it repelled, that means it's magnet, not magnetic material. What are some materials why are some materials magnetic? So we have magnetic materials. Why they are magnetic? You can think of a magnetic material as being made of lots of very small regions called domains. Each domain behaves like a tiny bar magnet. So look at this picture. Domains mean like small regions, okay, like regions or sections. So this is a magnetic material. Both of these pictures are like picture of magnetic material, but one of them is magnetic. This is magnetic, okay, and the other one non-magnetic. So when this magnetic material is magnetized, that means can attract, or we applied a magnetism on it using a magnet, okay? These domains, like these areas, okay, they will point to the same direction, but if this material demagnetized, that means we stopped the magnetism on it, these domains will point away from each other or in different directions, okay? As you can see here, the arrows. Each region will point to different direction, but if they magnetized, they will point in the same direction. So here, when a magnetic material is not magnetized, that means demagnetized, the domains are pointing in lots of different directions. This is not magnetized. If you magnetize the material by putting it near a magnet or stroking it with a magnet, that means like rubbing this material on a magnet, the domains line up, the material has been magnetized, like in this picture here. So what's about magnetizing and demagnetizing? How the material can, or how can we magnetize something or demagnetize something? Iron and steel are magnetized by being close to a magnet. Iron is easy to magnetize. You can pick up iron nails with a magnet. But if you remove the magnet and hold them up, they are no longer magnetized, so they fall. So like here in this picture, if we hold these nails with the magnet, they will line up like this, they will stick into each other, okay, and they will be magnetized. But if we removed it, they will fall like this one. If we remove the magnet, they will fall. They cannot hold the magnetism. You can make steel is harder to magnetize, but it stays magnetized when you remove the magnet. Steel pins or paper clips stay magnetized. So here, if we have steel nails, it's hard to make them attracted it's hard to attract them to the magnet, but if they magnetized or attracted to the magnet and we removed the magnet, okay, these nails will stay attracted to each other. They will just catch each other, unlike the iron. So the iron is easy to magnetize and easy to demagnetize, but steel are harder to magnetize and harder to demagnetize. You can make a stronger magnet from a piece of magnetic material such as steel needle, but by stroking the needle with a magnet repeatedly in the same direction. So if we have a nail or needle, steel needle, okay, we can scratch it or we can rub it at the same direction, okay, which is called stroking. We can stroke it with the same in the same direction many times. In this case, it will become magnetized. A piece of iron or steel that has been magnetized is a permanent magnet. So if we magnetized some materials and become magnetized, we call it permanent magnet. You cannot turn it off. You can demagnetize a magnet by heating it up or hitting it with a hammer. So we cannot demagnetize it if it became magnetized unless we heated this material or hit this material with a hammer. In this case, it will lose magnetism and it will become demagnetized. So now let's take a look over the summary of the lesson. The properties of magnets. Iron, cobalt, steel and nickel are all magnetic materials that are attracted to magnets. For magnets, like poles repel and unlike poles attract. This is called the law of magnetism. If we have North Pole, with North Pole they repel, South Pole with South Pole they repel, but North Pole with South Pole they will attract. You can make a magnet by stroking a magnetic material with a magnet, and this is called magnetize. So how can we demagnetize? As we said earlier, we can demagnetize a material by heating it up or hitting it by a hammer. This was all about properties of magnets. I hope you understood the lesson. If you have any question, write it down and don't forget the yellow box as homework. I hope to see you next time and see you in a new lesson. Bye bye.